We're recording, we are. We're turned the wrong way. All right. It's done normal. Let's make sure we can see this okay. Okay. Good. Backwards. Area shades. I think the most logical place is to shade it left since we drew it that way, yes? So left. What percentage? Just the 5%. Make sure you put it in correctly. I've seen many, many errors where you put in 0.5 or something like that. So 0.05. Here it comes. There it is, shaded right there. 0.64 standard deviations down. That's how many standard deviations. So you can tell the poor woman sitting in your office, don't worry. As long as you're above 1.64 standard deviations below average, everything is fine. To which case she punches you in the face. Because don't make her do the math. Do the math for her. You now know it's 1.64 standard deviations down. That does not tell you how many days it is. It's unitless at this point. How can we convert it? Come on now, lock up for me. How do we convert it? Yes! Well, actually, it depends if you like the formula or not. I like it. But you can also do it without the formula, right? What is 1.64 standard deviations in terms of days? What would you have to do with the 1.64 and the numbers? 1.64 times 16, that gives you how many days it is, yes? And then you just take that and do what with it? Subtract it from average, and that puts you down where you need to be. Now that's what the formula does for you, right? If you look at the formula, the forwards formula looks like this. X minus mu over little sigma. That's the forwards formula. If you solve that for X, you get Z times little sigma, let's put it this way. X equals mu minus Z, or plus, excuse me, plus Z times little sigma. It's going to be negative because Z is negative in this case. So when you do 1.64 times sigma, negative 1.64 times sigma, and then add it to mu, it's going to shift you down the correct amount. So you can totally use the formula if you want to, or totally just do it kind of crunch through logically if you want to. But either way, you know what these three numbers are. You know this is 266. You know this is negative 1.64, and this is 16. What does that all work out to be? How many days? Say it again. 240. 240? Is it around 240? To the nearest. There we go. And look at that. It makes perfect sense. Logically, it's right where it should be. Bigger than 234, less than 250. 240 days. You sneak in under that, your baby got considered preemie. And therefore, we got to take all the precautions that go with premature birth, lung inflator, things like that, little habit tent thing. But there you go. Now you've got a number, and you can put this person at ease, or make them more upset if they have their baby at 236 or something like that. But at least you have a number attached to it, right? Ask me that question, Aaron.
Well,
go.
We've gotten that 1.64 last time. So
say that again.
We got the same Z-score last time.
For what? Different context, right?
Yeah.
It was for...
Is it the same though?
It is. It is. 1.64, great question. 1.64 standard deviations always chops 5% in the left tail, regardless of context. IQ scores, pregnancy, ball bearing diameters, cylindrical gas tank volumes or cylindrical polypropylene glycol containers for solar hot water collect. Context is irrelevant. It will always chop 5% down. Just like positive 1.64 will make 5% up. Beautiful connection. It always is the same. There are certain numbers that as you do more statistics, you'll keep in your mind. 1.64 is the 5%. 2 is the 2.5%.
50 will always be 0.
50 will always be 0. These are the numbers that you'll see over and over again in the world. Somebody said somebody earlier said the 25th percentile The 25th percentile, somebody, when I was asking for guesses up there for the 25th percentile, this one isn't as popular, although it should be. It's negative 0.67. That's the 25th percentile. It's a little bit further, it's up a third from this. So those are just numbers that you're going to hear over and over again. So good connection. Yeah, it has to be the same. Perfect. Perfect. Other questions. Great connection. And thank you, Sean, for that, for the addition of the other ones as well. There are certain numbers, and that's the beauty of having the standard normal curve. They're all the same. They're always going to be the same on that curve. Then you have to convert them to the context you're talking about. Cool? Good connections. Other concerns, questions. I've totally ignored two great questions, which is kind of the opposite of the preemie. Which is what? Get them out, D's. Which means what? What is the get them outies? What's that? Say that again, I didn't hear it, Sean.
Just overdone.
Overdone, yes, exactly. Cooked long enough, get them out. So, the reason I wanted to analyze, this whole problem actually started, as most of the problems in your class do. They